All right, this is part 2 of the video for our review for chapter 1. We left off on question number 24. First thing that we need to do is we need to separate this into a couple different parts. So I'm going to draw on here some more lines to separate this figure into 3 separate shapes. And it's going to help us make this problem a little bit easier. Now, this is a longer problem, but I'm going to draw this line here. It's a horizontal line. So we have a triangle at the top. I'm going to draw another vertical line. So we have another triangle on the side, and then the leftover space is a rectangle. Now, we do have to perform either distance formula or Pythagorean theorem to find the lengths of the 2 sides for the outside of this figure. So let's start with that. We have either Pythagorean theorem or distance formula. So distance formula, it's on a reference sheet. It's distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. Now, Pythagorean theorem is c squared equals a squared plus b squared. Although these 2 formulas are actually the same thing, a lot of times it might seem easier to just use Pythagorean theorem. So on the top triangle, where we have the dimensions of 1, and then this entire length all the way across. So we're going from -4 to +3. That has a length of 7. So our 2 dimensions for our sides of this triangle are 1 and 7. So I can take those, plug into Pythagorean theorem. I have c squared equals 1 squared plus 7 squared. 1 squared is just going to be 1. 7 squared is 49. So together, c squared is 50. We need to take the square root. And in order to do this one, I am going to have to use a calculator because I don't know that one off the top of my head. So 50 square root. That's going to be 7.07. 7.07. Now, for the other triangle, I'm going to do the same thing. I'm going to use Pythagorean theorem. I have dimensions on this one of 1 and 1, 2, 3, 4. 4. So I'm using 1 and 4. We're in for my A and B. 1 squared is 1, 4 squared is 16. So we have a total of 17. Oops. We're going to actually take the square root now, 17. Again, I'm going to go over here to my calculator so that I can solve that one. 17 square root. We have 4.12. All right, so we have those lengths. Those are for the outside pieces of this figure. And we needed to figure out that outside piece because we're doing the distance around the figure when we're doing perimeter. So for the other 2 sides that we haven't figured out yet, SR, we can just count that. That's a total of 5 units. And then at the bottom, 1, 2, 3, 4, 5, 6. 6 units for the bottom. So doing perimeter, we're going to have 5 plus 6 plus 4.12 plus 7.07. So again, those are the lengths of the outside pieces. Add that all up. So again, going back to my calculator. 5 plus 6 plus 4.12 plus 7.07. All right, so our answer here is 22.19 units. And that's our perimeter. So that's our first answer using that diagram. For the other one, let's swap out some colors here. Let's go with green. All right, now we're looking at the 2 or 3 shapes. We have a rectangle. In order to do area of a rectangle, we're going to do, oops, I started writing it again. Area equals base times height. So area equals base times height. What's our base? What's our height? Well, we have 6 on the bottom. We have 4 on the side. So it's just 6 times 4. So that's an easy one. Area of the rectangle is 24. For the triangles, now we have two triangles. We have 1/2 base times height. For the triangle, the first one, area equals 1/2. We have a base of 7, a height of 1. 7 times 1 is 7, and then half of 7 is 3.5. For the other triangle, we have 4 and 1. So area equals 1/2. 4 times 1. 4 times 1 is 4. Half of 4 is 2. So we have the area of each of our individual pieces. The overall area can be found by adding those up. We got 24 plus 3.5 plus 2. Now, using that calculator over there off to the side, we have a total. What did I say? 24 plus 3.5 plus 2. I don't know why I actually used a calculator for that one. Probably didn't need it. 29.5, and that's units squared. All right, so that was the bottom of the piece that we're missing from 1/4. Now let's go ahead and scroll this up and get over to 1/5. So I'm going to clear this off. Let's scroll it up. I'm not going to be able to fit the entire thing on here. So again, this is for 1/5. Now, for this one, they are having us use angles, and we're looking at angle addition postulate here. So we know that the two small angles have to equal the bigger angle. Well, they told us the actual size of the bigger angle. Now, since we know that, we're just going to write an equation where the 77 is equal to the two smaller angles added together. So the 3x plus 22 plus 5x minus 17. 77 equals, combine like terms here, 3x and 5x is 8x. 22 and negative 17, that's going to be 5, positive 5. Bring the 5 across by subtracting it, again, inverse operations. That leaves us with 72. Divide 72 by 8, and x is 9. Now again, that's not where we're stopping. It wants the actual angle measures. It says find these two angles. So you have to take x and plug it back in for each of those expressions. So for the first expression, we have 3 times 9 plus 22. For the second expression, it's going to be 5 times 9 minus 17. 3 times 9, that's going to give us 27. And 27 plus 22 is going to be a total of 49. On the bottom one, 5 times 9 is 45 minus 17. That's going to give us a total of 28. Now, if I want to double check to see that I did this correctly, again, these two measurements that we got. So this first one is ABD. The second one, 28. That's going to be DBC. And I should also include my degree symbols on that. But to check my work, add them together, you should get the original angle measure, which was 77. 49 plus 28 does equal 77. So we did it correctly. On 27, we're now going to do the same thing. We have our angle, our big angle is 111. So 111 is equal to, and then add these up. That's going to be, that's smudge on my screen here. Yeah. So that's going to be equal to negative 10x plus 58 plus 6x plus 41. Combine like terms. Negative 10 and positive 6 gives us negative 4x. 58 and 41 is a pretty big number. That's 99. So now get rid of the 99 by subtracting it. It leaves us with 12 equals negative 4x. Finally, divide off 4, -4, and x is -3. It's okay to get a negative value for x. We should not get a negative angle measure. So at this point, we're still safe. We just need to make sure when we plug it in, we get a positive number. So on here, we plug in -3 to this first equation. We have -10 times -3 plus 58. -10 times -3 is +30, and +30 plus 58 is 88. So 88 degrees for the first angle. The second angle, take -3, plug it in. So we get 6 times -3 plus 41. 6 times -3 is going to give us -18. And then -18, let me actually write that one down, -18 plus 41. So that's a difference of 23. So we have 23 degrees for the smaller angle. Again, check your work, add them together. 88 plus 23 is 111. So we did the correct work. So again, our two answers, 88 for ABD and 23 for DBC. All right, on 28. This one said, find the measure using a protractor. Now, I had you doing this on the computer. They actually provided a protractor on the computer. So we just want to make sure. I'm going to just draw a protractor real fast over this, just to get us an idea of what this looks like. Oops. Something like this. And again, this piece, the vertex gets lined up on the one line. You'll have a 0 line coming this way that lines up with this. So we have a 0 mark over here. Now, coming all the way around over here, if you have it lined up perfectly accurate, this one had a measure of 127 degrees. I just remember this from doing it in one of my classes earlier. So is it going to be perfect? Probably not. So they said they accepted answers plus or minus 1. So anything from 127 would have worked, 128 would have worked, or 126 would have worked. Those were acceptable answers using the protractor on the screen. You will not be using that protractor during the test. Instead, on the test, the protractor will already be drawn over the angle that you're measuring. All right. All right, I think there's one more down there. So let's clear this off, scoot this on down. Yeah, so 29. All right, on 29, given that P is the interior of angle ABC and measure of PBC is 30 degrees, measure angle DBC is a right angle, and measure of angle ABD is 26 degrees. What are the possible measures of angle ABP? Now, it doesn't say what is the measure. It says what are the measures, possible measures, plural. So they're actually looking for more than one answer here. And if you're doing this online, you saw there's 2 blanks. So there are actually 2 drawings that would fit this. So first thing that's important is actually draw this out. So I'm going to draw an angle to start with and call this angle with some points, A, B, C. Now, the problem is that original angle, we don't know what that angle looks like. It could be an acute angle, it could be an obtuse angle, or it could be a right angle. Now, they do tell us that DBC is a right angle. So probably not going to be a right angle because they give us some other measurements that rule that out. But they don't give us anything to rule out the possibility that ABC is an obtuse angle. So I'm going to do 2 drawings for this one. And this is why we end up with 2 separate answers. So A, B, C. Now, the other information they gave us is that P is on the interior of ABC. And they told us that PBC is 30 degrees. So I'm going to draw another segment here with P on it. and label this angle as being 30 degrees. Then they said that DBC is a right angle. So I'm going to go ahead and draw a right angle. I'm going to label it as such. I'm going to put a point up here. That's going to be point D. Then it tells us that ABD is 26 degrees. So in the first diagram, ABD is this angle. I'm going to put 26 in there. But then in this other drawing, this would be ABD. So this one's 26. So we are trying to find this value right here in both of these figures. In each one, it's slightly different. So in the first diagram, dealing with the acute angle that we had drawn first, we have a right angle. We can subtract off the two other pieces that we know are part of that right angle. Or if we want to make an equation out of it, 90 equals 26 plus 30 plus x. All three of those together would have to equal that 90. Combine those two, that's 56 plus x. Subtract off the 56 that we already have, that'll be 34. So one possible answer is 34 degrees. The other answer, though, over here, well, on this one, if this is the right angle, yeah, if this is the right angle, actually, this is not the angle we're solving for, but we do need this one first. So this missing angle, if we have the right angle and the 30 degrees, we can subtract 90 minus 30 and get that this one is 60 degrees. However, this time it's this angle that we're looking for, ABP. So we need to add 60 plus 26 and get a total of 86 degrees. So that one was a little bit confusing and complicated because there was multiple answers. And again, that's why we had two different answers. You had either the possibility of an acute angle with ABC or an obtuse angle with ABC. Hope that helped that question. All right, on to the last section. Let's go ahead and clear this. All right, 1.6. So we have angle 1 and angle 2 are complementary angles. Given angle 1, find angle 2. Well, if they're complements, that means that they add up to 90 degrees. So 90 minus 12 is going to give us 78 degrees. On the next one, 90 minus 83 gives us 7 degrees. That's it. On the second set, supplementary angles. Again, they told us 3 and 4 supplementary. They gave us angle 3. They want angle 4. So this time, subtract from 180. 180 minus 116 leaves us with 64 degrees. For 33, we have 56 given to us. So 180 minus 56, that gives us a total of 124 degrees. All right. Number 4, construct a linear pair where one angle measure is 35 degrees. Label the measure of both angles. Construct a linear pair where one angle measures 36 degrees. On this one, I feel like there's a mistake. I think really they just want us to draw because we cannot actually physically construct that. Construct is the wrong word. So we're going to say draw a linear pair where one angle measure is 35 degrees. Label the measures of both angles. So a linear pair, we're going to have a straight line. We're going to have another line coming off of it. We're going to say that that angle measure, the smaller one, is 35 degrees. And then the larger one would have to be 180 minus 35, which leaves us with 145 degrees. So something like that would be a good drawing. Didn't say we had to label any points, so that's all we needed. All right, on the next one, the measure of an angle is 4 times the measure of its supplement. Find the measure of both angles. Well, if we know their supplements, you could draw a picture if you want to. You don't have to necessarily on this one. But let's say that this is one angle, the other angle is 4 times that. So calling one x, we're calling the other one 4x. Together, they have to add up to 180. So 180 equals 4x plus x, or 180 equals 5x. Divide by 5, that gives us 36 equals x. And once you know what x is, well, one of the angles was 36. The other one is 4 times that. So let's see, 4 times 6 is 24. So carry that 2. 4 times 3 is 12. So 144. And if you want to double check, add those up, they do add up to 180. So find the measure of both angles. The two angles are 144 degrees and 36 degrees. Yeah, that all went with this other problem down here. All right, on 36, find the measure of angle ADB. ADB. It told us that, oh, and they wanted BDC. So both of these angles here, which they form a linear pair. So knowing that they form a linear pair, they form a straight line. We know that they have to be equal to 180. So we can say 180 equals 6x plus 10 plus 4x. Combine like terms. 6x and 4x is 10x. Subtract the 10, the constant 10, from the other side. So that leaves us with 170 equals 10x. Divide by 10, and you get 17 equals x. We still need to plug it back in to find out those measures. So for the first one, 6 times 17 plus 10. Actually, let's go down this way. Let's see, 6 times 7, that's 42. Carry the 4. Next, 102 plus 10, that's 112. All right, that's for the first angle. All right, that's one answer. The other one, 4 times x, so 4 times 17. 4 times 7, that's 28. Here the 2. 4 times 1 is 4 plus the 2, 68. And if we want to double check our work, so our two measurements are 112 and 68. And if you add them, they do give you 180. So we did it correctly. And that is the rest of the review. If you didn't see the other video that had numbers 1 through 23 on it, then you can go back and watch that if you want to. Again, make sure you are prepared for the test. Make sure you study. Make sure you use your flashcards to review over your vocab words. And I will see you tomorrow.